generation of FM. There are two types of method. One is direct method and another one is indirect method. Direct generation, and then next indirect generation. So in the direct method, we'll be using the concept of voltage controlled oscillator. Okay, by default, the name itself indicates oscillator means it will produce frequency. So that frequency can be controlled by the input voltage. So for the input of VCO, I will be giving the message signal. So at the output, I will be getting the variation in the frequency. So using VCO, voltage controlled oscillator, or using parameter variation technique. Maybe in the microwave devices, you will be studying this kind of technique, parameter variation technique. And then in the indirect method, we'll be having the Armstrong method of FM generation. Armstrong FM generation method, and also varactor diode. But mostly they will ask this in the exam. Armstrong FM generation is the indirect method of FM generation. That means here what we will do in case of indirect, mainly, first we will generate narrowband FM signal. First we will generate the narrowband FM signal. Then we will pass it through a multiplier. Again, that multiplier output will be wideband FM signal. That multiplier output will be the wideband FM signal. That is the concept of indirect generation of FM signal. First narrowband FM generate பண்ணினோம், அதுக்கப்புறம் அந்த மல்டிப்ளையர் வழியா பாஸ் பண்றோம், ஃபைனலா நமக்கு wideband FM signal வந்து கிடைக்கும். So now in general we will have some equation that may be narrowband or wideband, but once if you pass it through a multiplier, what will be the output, that we will see quickly now. So I am having some multiplier. Multiplier means with the factor of n. Multiplier with the factor of n. So I am having multiplier with the factor of n. N may be 2, 3, 4 like that. I am giving some FM signal, say S of t. I will mention AC cos 2 pi FCT plus beta sin 2 pi FMT. So I am having some FM signal. I am not mentioning whether that FM signal is narrowband or a wideband. I am having some FM signal. I do not know what is the value of beta. It can be anything. But once if I pass that signal through multiplier, what will happen? What will be the output? Just you multiply this n inside. That is the concept. So what we will get, S of t AC cos. Now this n will be multiplied inside of cos. So here I will get n times. So n times of 2 pi FCT plus n times of beta sin 2 pi FMT. Now you have to be very careful here. I am taking this n inside of cos, but this n cannot go inside of sin. That is very, very important. This n is present here, but not inside of sin. So you have to be very careful here. Now, I have taken FC here. I have taken beta. Now, this FC has changed to NFC. Originally, this is FC. But once if we pass it through a multiplier, that carrier frequency will become n times of FC. Now, similarly, the modulation index beta is also converted into n beta. But now the question here is, beta is converted into n beta, but that beta consists of two parts. And one more thing, you have to understand, there is no change in the FM. See, observe here, FM is there, here also FM only. There is no change in the FM. FM is FM only. There is no change in the FM. So you can observe 3 parameters here. Okay, FC is converted into n times of FC. beta is converted into n times of beta, Fm, there is no change. There is no change in the message signal frequency. There is no change in the message signal frequency. Now, the question here is, will there be the change in the frequency deviation? That is another question. So now we have to define what is the del f. Say we know del f formula, beta is equal to del f divided by Fm. Beta is equal to del f divided by Fm. Just now we have seen there is no change in the Fm, but beta, there is change in the beta. Beta is becoming like n beta. That means the only way is there must be the change in the frequency deviation. Once if you pass the signal through multiplier, this is the hidden factor. So that I'm writing here, del f will be changed as n times of del f. Del f will be changed as n times of del f. So you have to understand this very carefully. You are having some signal, if you mostly Fm signal, if you pass it through a multiplier, what will be the parameter change? Del f will be multiplied by n, Fc also n, beta also n, but there is no change in the Fm. Again, the del f concept is somewhat indirect. You have to understand this. Okay. Again, sometime in the exam, they will ask this kind of question also. Instead of multiplier, they will use frequency translator. They will use frequency translator. What is the concept of frequency translator? Say, if my spectrum is available at Fc1, after passing through that frequency translator, instead of Fc1, I will have some other frequency, Fc2. That means entire information present around Fc1 will be diverted to Fc2. That is the concept of frequency translator. That time also they will ask what are all the changes in the parameter. That time also they will ask what are all the changes in the parameter. And mainly they will ask, will there be any change in modulation index, beta? Will there be any change in the modulation index? I'm having some signal with some modulation index beta, and it is converted into around other frequencies, other carrier frequency by using frequency translator. Again, how this frequency translator, the another name for frequency translator is mixer. Another name for frequency translator is mixer. Mostly they will mention like mixer. If I'm passing through mixer, then will there be any change in the modulation index? There is no change. Mixer will not change the modulation index. Again, by default, if it is modulation index, I am mentioning beta. If there is no change in beta means definitely there will be no change in the frequency deviation. So mostly mixer will not change the frequency deviation. So very important note, mixer will not change the frequency deviation. Mixer will not change the frequency deviation. Very important note. But in the previous case, we have discussed multiplier. Multiplier, this is the concept. But for mixer, there will not be change in the frequency deviation. So next, finally, we will see the demodulation of FM signal. Demodulation of FM. Here also two varieties are there, like direct and indirect. Direct and indirect. Under the indirect method, we are having PLL, phase locked loop. Most of the time, you'll get question based on this. PLL is the indirect FM detector. PLL is the indirect FM detector. PLL means phase locked loop. Phase locked loop. Indirect கேட்கறதுக்கு பதிலா டைரக்டா கூட கேட்பாங்க. டைரக்டா क्वेश्चन எப்படின்னா which of the following is the FM detector? அதுல PLL இருக்கும். ரிமைனிங் AM demodulator கொடுத்திருப்பாங்க. அப்போ PLL நீங்க என்ன பண்ணணும்? கேர்ஃபுல்லா வந்து சூஸ் பண்ணணும். In case of direct, there are two methods. One is slope and another one is phase. Another one is phase. In case of slope, again there are two methods. One is simple slope and balanced slope. Simple slope and another one is balanced slope. In case of phase detector, in case of slope technique, and another one is phase technique, here itself there are two categories. One is Foster-Slade discriminator and another one is ratio detector. Foster-Slade discriminator and another one is ratio detector and another one is ratio detector. So these are all the demodulation technique, but mostly you'll get question based on PLL. So now what is the concept of FM demodulation? For demodulation of FM, what is the basic technique actually? So I am having S of T. S of T is the FM signal. Okay, in any technique other than this PLL technique, okay, other than this PLL technique, in any of this technique, mostly we will be using this concept. Now I'm writing the concept of FM demodulation. Concept of FM demodulation. Concept of FM demodulation. Already we know how to detect the AM signal. AM signal can be easily detected with the help of the asynchronous detector, that is the envelope detector, asynchronous detector or envelope detector. So once if I'm having FM signal, just pass it through a differentiator circuit. You take the differentiation, then after that, if you do the differentiation operation for FM signal, almost the amplitude, almost this will resemble somewhat similar to AM signal. If you carefully observe, after doing the differentiation, at least the information will be present in the envelope, because in case of AM, the information is present on the envelope, okay, in the same manner. If for the FM signal, if you take the differentiation, the information will be somewhat available at the envelope. That means if the information is available at the envelope, we can consider like a AM signal. If it is a AM signal, we can use envelope detector. Then finally we can get the message signal. Finally, we can get the message signal. This is the concept of the FM demodulation. Sometime you may get question based on this also. This is the concept of FM demodulation. FM signal irukku, one time differentiation manina, it will be somewhat similar to AM signal. I am not telling exactly it is AM signal. That information will be available at the envelope. M of T will be available at the envelope after doing differentiation, will be available at the envelope. Once if information is available at the envelope, you can use envelope detector. From that you can get the message signal.